Hello and welcome to Chemistry with Mr. Olson. Today we're going to use this ratio, 22.4 liters per mole, whenever possible, whenever we're at STP. And we'll solve a couple of problems on our worksheet. Question 12. What's the volume of 1.30 moles of gas at minus 30 degrees C and 1.10 atm? Well, we're clearly not at STP there. Let's identify some variables. We've got, what's the volume? That's V. 1.30 moles is N, little n. The gas is at minus 30 degrees C, that's the temperature. And here we have the pressure. So, P, V, N, and T. This is an ideal gas law problem. So let's write up here at the upper left, PV equals nRT, our ideal gas law. And let's see. We want to solve for V. Much easier to do algebra on variables. So V equals nRT over P. T over P, and we equals, let's write a nice long line there, and let's substitute. 1.30 moles is N. R, I'm going to do in a different color. Let's do it in green so it stands out. R, looking that up, our gas law constant, 0, and we want to use the one with ATMs if we have a choice. 0.0821 liters times atmospheres over Kelvin times mole. There's our R value. Extend this line a little bit. And nRT. T is minus 30 degrees C. But we don't want to enter degrees C here, we want to use Kelvin. So T plus 273 is 243 Kelvin, and we divide by P. So P is 1.10 atm. And now we can cancel units. Moles cancels moles. Kelvin cancels Kelvin. ATM cancels ATM. We're left with liters, which is good. And we do the math, and the answer comes out to 23.6 liters. So there's our answer, 23.6 liters. Okay, next problem. Problem 13, how many moles are in 3.20 liters of a gas at STP? Now this problem could be done using the ideal gas law. However, much better to use that ratio that's true of any gas at STP. So it's just a very simple conversion. We take our 3.20 liters, multiply it by a conversion factor, get out of liters into moles, and 1 mole at STP is 22.4 liters. And doing the math, that comes out to 0.143 moles. 0.143 moles. Okay. The last problem we're going to do is a stoichiometry problem on the back. And we'll have to zoom out just a little bit. Whoops. And let's see. Nitrogen gas and hydrogen gas react together. So our reaction is N2 plus H2 react to form, and we see it's talking about ammonia. It reacts to form ammonia, NH3. Now we need to balance this. So let's see, we're going to need 2 ammonias and 3 hydrogens. Now it's balanced, and we can answer the question. How many liters of ammonia gas will be produced when 90 grams of nitrogen gas reacts? So we're going to convert 90 grams of nitrogen gas to some quantity of ammonia, and all roads lead through moles, so we'll go from grams to moles to liters. Let's start with our given. Our given is 90 grams of N2, and we're going to get out of grams of N2 into moles of N2. And 1 mole of N2 has 2 nitrogens, 2 times 14, 28 grams per mole. But we don't want moles of N2. We want moles of NH3. So this is our mole-to-mole ratio. Fill in the numbers from our balanced chemical equation. 1 mole of N2 gives us 2 moles of NH3. Okay, and then one more conversion factor. Out of moles into liters. Out of moles of NH3 into liters of NH3. Because we are at STP. This reaction is occurring at STP. So 1 mole is 22.4 liters, using that very convenient conversion that's true of any gas at STP. Let's cancel our units. Grams of N2 cancels grams of N2. Moles of N2 cancels moles of N2. And moles of NH3 cancels moles of NH3. We get our answer in liters of NH3. And putting that into our calculator, we get the answer 144 liters of NH3. And there is our answer. So remember, whenever you see STP, it's like a code word that says use this conversion factor, 22.4 liters per mole, a fact that's right on your reference sheet. And also, when you're doing stoichiometry or many other problems, remember that all roads lead through moles. Convert to moles, and then you can use the balanced chemical equation to go from moles of one thing to moles of another. And hope you have a wonderful evening. Ta-ta.